The y-intercept is where the graph crosses the y-axis. If you are given an equation, you can find the y-intercept by substituting in 0 for x. You essentially cancel out the x part. When you write your y-intercept, you need to write it as a coordinate point. X is 0, and then your number goes here, whatever your y-intercept is. Let's do a few examples. If I give you an equation, you should be able to determine the y-intercept. Find the y-intercept of 3y plus 2x equals -6. If we're looking for the y-intercept, we want to keep y in the equation, but we need to get rid of x. X is 0 for the y-intercept. So every x that you see, you replace with a 0. Well, 2 times 0 is 0, so this whole thing is 0. And 3y plus 0 is still just 3y, so I don't really have to write that other x part that's now nulled out. Solve for y, so I'll divide by 3, and my y-intercept is -2. Make sure you write your answer as a coordinate point though, so x was 0 and y was -2. Even if our equation looks a little bit crazier, it's still going to be the same rules. Everywhere you see an x, substitute all of the x's with 0. Calculate that in your head or type it into your calculator. Either way, you should end up with, this is a 0, minus a 0, minus a 0, plus 8. You end up with y equals 8. So my y-intercept is 8. Don't forget to write it as a coordinate point though. The x values were 0, the y value was 8. And again, even if you see a crazy equation like this, it's going to be the same rules. Replace all of your x's with zeros. Type that into your calculator or do it in your head. This time, since we aren't multiplying yet, it's 0 minus 1. That's a -1. And 0 plus 3, it's a 3. So I can't just null those out. They're not all gone away. This ends up being 9. 3 squared is 9 times -1. So -9 times 3 is -27. Write it as a coordinate point. And this is your y-intercept. The x-intercept is pretty much the same idea, except we're going to switch all my x's and y's. The x-intercept is where the graph crosses the x-axis. If I give you an equation, you can find the x-intercept by substituting in a 0 for y, and we write our coordinate point. We have a number for x now, and y is the 0 part. So determine the x-intercept of these equations. I want to cancel out the y piece, so replace all of the y's with zeros. 3 times 0 is 0, and 0 plus 2x is still just 2x. Solve for x. So my x-intercept is -3, but remember you need to write it as a coordinate point. X is -3, y is 0. Coordinate points are written x, comma, y, so make sure you put the 0 in the right spot. Same idea, I can find my x-intercept. I want to cancel out the y, so replace all of your y's with zeros. 4 times 0 is 0. 2x minus 0 is still just 2x. Solve for x. So my x-intercept is 4. And don't forget to write it as a coordinate point. Both of these examples, my x-intercept is a whole number, but know that you can have fractions. I just did not give you examples of fractions, but it would be the same idea. If this had been 8/3, you'd just write an 8/3 here. One more piece. What if you have something a little bit crazier like this? It's not going to be quite as straightforward because it's not a line, but we can still solve things even if we have exponents here. Just like before, replace your y's with zeros. Now what? Anytime you have something equal to 0, that's a key to you solve it. So this is a quadratic, it's x squared. How do we solve quadratics? You can either factor them, complete the square, or do the quadratic formula. This one is quick to factor. You come up with two numbers that multiply to -40 and add to -3. Once you have it factored, set each factor equal to 0 and solve. So for this example, I have two x-intercepts, and actually I should write them both as coordinate points. You would need to include both coordinate points when you write your final answer.